In the previous lesson, we saw a couple examples of some very common methods that you would expect to see on companion objects for most classes that we might define. We saw apply and unapply. And the thing about them is that they follow a pretty conventional pattern. Apply is going to take probably the same arguments that our constructor takes, and then the implementation of apply is just going to delegate to the constructor. So that's not very interesting. Unapply, likewise, it's probably going to take an instance of the class that we're matching on and decompose it into a tuple wrapped up in an option. So you can imagine writing both of these probably more or less the same way for most classes that you'd care about. We saw that you could play around with unapply to do different things, but probably for the majority case, these are going to follow the same pattern over and over again. We call that boilerplate, and boilerplate is something we like to avoid, right? We want to spend most of our time writing interesting code, not repetitive code. Now, since we're on the JVM, there's also a bunch of boilerplate that we sort of inherit from the Java world. We probably want something like an equals method, and a hashcode method, and a toString method, things like that. Because, for example, if we go over to the console, let's create two empty recipes and see what happens if we compare them. Alright, so we've got two different recipe objects, and they're empty, but that's okay. And let's try to compare them now. Let's say R1 equals R2. Huh. Well, we'd really like these two things to be equal. We'd like to be able to say R1 equal R2, and actually have that return true because they have the same contents. In Java, the way that you would do that is you would override the equals method, and you would provide a structural comparison. Likewise, you'd have to override hashcode. You have to do that in a way that's consistent with equals. And then the other thing that we can see here is that the default toString implementation for our recipe class is just, again, object.toString, which just prints out the type and the memory address. It's really not very useful. We don't want to have to write all that stuff out. So instead, in Scala, we can actually eliminate all of this boilerplate by using something called a case class. So I'm going to delete the companion object, call recipe a case class instead, and we should be good to go. So what's happening under the covers here? It turns out the compiler is actually generating a companion object. The companion object has an apply method, and it has an unapply method, and they're implemented pretty much the same way that we implemented them by hand. It's such a common pattern to do that the language just takes care of it for us. It also implements a toString method. It implements an equals method and a hashcode method, and several others, which we're not going to talk about. And in fact, there's another little bit of boilerplate here that we've sort of taken for granted. The fact that we had to declare ingredients as a val to turn it into a field rather than just a constructor parameter. That's also boilerplate. We can leave off val if we make this thing a case class. So let's save this and see how it works. We're going to create two new recipes again. At this time, there is a slight difference. The apply method that the compiler automatically generates for us isn't quite smart enough to provide empty lists as default, so we have to do that ourselves. We'll say list.empty and list.empty. Okay, and likewise, we can say R2 equals a recipe that's constructed the same way. Now, the first thing that we notice is that it's not showing us the memory address anymore. It's actually showing us that this is a recipe containing two lists. So that's good. And if I say R1 equals R2, it'll say true. It's doing a structural comparison on the two. And we can also use these in pattern match expressions as well now. The unapply method was generated for us. So we can say something like cookbook.pbj match case recipe of, let's extract the ingredients and the directions again. So this is great, right? Simply by saying case class, we got apply and unapply for free. We got equals and hashcode and toString for free. We also get something called copy for free, I should mention. cookbook.pbj.copy. And that'll give us a fresh copy of the same object, which it probably isn't all that useful by itself, but we can modify the fields when we make a copy. So we can say ingredients is equal to, let's just say an empty list. Okay, so this gives us a copy of the peanut butter and jelly recipe, except for we've thrown out the ingredients. So we get all of that for free when we declare a case class. Now, finally, why are they called case classes? Well, maybe it seems like a little bit of an arbitrary choice, but they're called that because you use them in pattern matching. So case class is very useful for us when we want to define the data model that our program operates on, and so that's what we're going to use them for going forward.